Here. Thank you, everyone. Today I will be speaking about libraries, copyright, I'm not a lawyer, full disclaimer, and language models. So, to give you a little bit of background, this is of course generated by ChatGPT. I'm not an illustrator either. We're living in a revolution of large language models in the field of natural language processing. These artifacts are in our everyday lives. They have become our companions. They have become mainstream now. Everyone knows what an agent is. Everyone talks to these AIs in WhatsApp, in the web, in many different ways of accessing and interacting with them. They have become part of our everyday life. However, not everyone understands that these artifacts, these models, or whatever you might want to call it, they need vast amounts of textual data. Probably all of you know that, but not everyone who uses these artifacts know about how they are trained. This obviously poses a lot of legal and ethical questions regarding the copyright protection of these materials. Very recently, it was discovered by some leaks in the internal email system at Facebook that, for example, a whole family of these models seem to have trained using pirated books through a website called LibGen, who hosts, in violation of copyright, many thousands of books or articles and so on. If we take a brief look at the timeline, in November of 2022, OpenAI released ChatGPT. That was a breakpoint in the history of AI, because after that, everyone knew what AI was, what language models are, and you can now talk to anyone about language models, and they immediately know what ChatGPT is. That's also something negative, because every time you try to talk to them about language models in a more general sense, everyone compares whatever you're talking about to ChatGPT. And ChatGPT is a bit ahead of everyone else. So when you are developing language models, it's a bit of an unfair advantage to get compared to ChatGPT all the time. But that's how it is today. A few months later, in January of 2023, GPT-4 was released by OpenAI as well. That was probably the first time that we started to see human-like capabilities in these weird artifacts that try to talk like people. Of course, that was raising a few concerns, especially in right-holder organizations representing the book industry and publishing houses for newspapers, because in a way, it was threatening their way of life, the way they're actually making money. They got a bit angry, and they started a lot of different lawsuits, many different representative organizations of many different media types, from books, newspapers, music, code, images, you name it. They all started litigation against all the companies. And at some point, it also reached Europe. Most of this happened in the US, but at some point, they also reached Europe. We are a bit ahead in terms of legislation. We have the AI Act, we have the Text Mining Directive, we have a lot of different provisions, and not all of them are enacted law in every country, but at least we're a bit ahead in terms of protections. However, the litigation trend also got to Norway. And in November of 2023, the Rights Holders Organization of Norway wrote a letter to the Norwegian government. They were demanding compensation for the use of their material in the training of these large language models. As a result, the Norwegian government, specifically the Ministry of Culture and Equality, asked us to the National Library to conduct some research to assess if using publisher control copyrighted protected material was having an impact on the performance of these large language models. And if so, if it was the case that actually using this material was making the models better, we should try to establish a compensation scheme for the authors. That's how the project Mimir was born. This is the actual mandate that we got from the Ministry of Culture. First, we have to examine the value of copyright-protected material in training Norwegian generative language models. And I have to emphasize generative because we have been training models in the past that were not generative in nature. They were not able to produce text. They were not able to generate textual content. They were AI models. They were language models. They modeled the dynamics of the relationships between the words, but they were not able to write some sort of paragraph for you or answer your questions or write in the style of Ibsen. These models are called technically BERT, or encoder-only model. BERT is one of the most prominent examples of an encoder-only model, and they are used to classify text. You can ask it to classify sentiments, you can ask it to classify reviews, you can ask it to classify whether two paragraphs are speaking about the same topic. It's all about classification, either at the word level or at the document level. But they were not producing text. It's when these models get generative that it becomes problematic for copyright. As a second goal of the assignment, we needed to assess the basis for a possible compensation scheme for the Norwegian right holders, and also prepare proposals for this very compensation scheme. The Mimir project was only concerned with Objective 1, while Objectives 2 and 3 were outside of the Mimir project, even though they were still carried out by the National Library of Norway. Fortunately, I was not part of the negotiations with the right holders. Those can get sometimes a bit tense. So I'm happy I was not part of them. So the problem with this project is that we needed to devise the whole life cycle of models, from the gathering of data to the training of models to be able to compare, do some ablations to see how different subsets of the material were affecting the performance of the models, and also do evaluation of this. And doing evaluation of language models in Norwegian was a bit complicated because unlike English or Chinese, we didn't have that many data sets to test our models on. So we have to build a lot of this from scratch. The issue is that we were given 6 months and no money to do all of this. There was a challenge, I can tell you that. But we were tasked to coordinate this effort and get in touch with other universities and research organizations to be able to successfully complete this project. So we got in touch with the University of Oslo and the Technical University of Science and Technology, NTNU, in Trondheim. And they were ecstatic to participate in this project. So we made some sort of consortium, and then we split the different responsibilities of the project. We also were lucky to come with Sigma 2, which was providing access to the supercomputer Lumi, excuse me, in Finland, and a tiny bit of help, very tiny, from Google Research, providing TPU, that is just compute, in the form of accelerators for the training of these models through personal TPU research program grants. Those are assigned to different individuals, but you are basically allowed to use it for whatever research purpose you want. The National Library was tasked with the coordination of the project, but also with the data curation. We are masters of our collections. We know them better probably than anyone. So we were in charge of actually producing the training material for these language models. NTNU was tasked with the design of the training process, how many models, how they are trained, for how many steps, batch sizes, learning rates, all of those nitty-gritty details that you still need to produce good performing models. And University of Oslo was tasked with the evaluation. That was a massive task, because they have to build all of these data sets mostly from scratch. They, as you will see later, they were using English as a reference, but most of the time, the English made no sense. And when you try to localize it, it didn't even make less sense, so they have to basically rewrite almost everything. And then for compute, we use Lumi, Sigma 2, and Google Research. So you might be wondering why the National Library was tasked with this, and that's because we already have a massive collection of digitized material. The National Library was established in 1989 with the purpose of preserving the published information for posterity and giving access to its content to all Norwegian citizens. After the 2005 manifesto, we started our digitization practice, and it's been going on for 20 years. So after 20 years of digitization, we have almost all the books already digitized, almost all the newspapers already digitized. We have everything in the radio archive. We do continuous harvesting of the web, as you all know. But we have much more. We have photo, film, maps, etc. The digitization was at a level that allowed us to carry this project. We've been digitizing newspapers. We also got creative sometimes. We have to bundle newspapers together, and then we put it in a volume that is ready to put in the book scanner, and the scanner does its job, and then we get the results of the scanning out. We've been doing this for a number of years now. But also, the legal framework was allowing us to take on this role. We have a thing called the language technology purposes, the SPRAC technology for MOL, that allow us to use our material for research in language technology. We have the language bank that was established precisely to foster the creation of language technology corpora. We have Legal Deposit Act that allow us to actually host all of this content and get copies from the publishers directly sometimes. And we also have the Copyright Act. On top of this, the right holders agreed to this project Mimir for research. So after some digging in our collections, after some thinking, we decided to create two different sections of the data. We have what we call the base, which includes open data from the internet, data that is free to access, that is available without restrictions. We also have newspapers and books in the public domain, or that by agreement we can use. We also have publication from the public sector, the parliament and the government, and arranged data that is already available by the language bank. And then we have the extended, which is the same as base, but also including copyright-protected material for newspapers and books that we have in our collections. Turns out that not every time the agreements are what you think they are, because in some cases, these agreements predate large language models, and they need to be renewed in the light of new generative AI. So it's just fair to rethink these agreements, and sometimes we have to withdraw some material because they needed to be reinterpreted for the new purposes that we were using this material for. We collected around 60 million documents in the base data set. That's like 40 American billion words. And the extended is basically double the amount. This is the distribution of the different sources that we have in our data sets. From the raw, this is just the raw counting of words, space separated, nothing fancy like tokens or anything like that. This is just counting words split by space. And we're using the books in our collection. We are using Cultura X, which is using Common Crawl as a source. through OSCAR and MC4 datasets that probably all of you know. We also have digitized manuscripts. We have evaluation reports from the government. We have data from the High Performance Language Technology project in Europe, which is doing its own harvesting of the web and also providing training sets for language models. We have LOF data. Oh, there is a typo there. LOF data, which is the textual form of the laws in Norway. Molfrid, which is a collection that the Language Bank does every other year about all the information published by the government. We have open newspapers, Parliament, we have books in English from Project Gutenberg, some code that we added, and Wikipedia. On top of that, we also have the publisher control, copyright protected material for the books and the newspapers. You can see how the sizes get smaller and smaller in every column. From the raw material, then we clean it and deduplicate it, then we do language balancing because we didn't want to overwhelm these data sets with English, which is basically everywhere. And then the base, you can see how, you can see in the base data set how these amounts get even smaller, and there is basically zero material from the books and newspapers. We have to count these many times to make sure that no material from the copyright holders were actually included in the base model. There is a lot of tiny details that we have to control for. In terms of languages, we didn't want to overwhelm any of the Scandinavian languages, especially Bokmål, which is the written form, the official written form in Norway together with Nynorsk. But there is probably a lot more of Bokmål than Nynorsk. So around 35% of the entire extended corpus was Bokmål. But we also included Danish because they are, in a way, similar. English, Icelandic, Nynorsk, and Swedish. But we decided not to upsample the smaller languages. This is like a tree map of how the material actually looks like. You can see how the internet crawl material coming from Cultura-X and HPLT makes for around a bit less than half of it. And then you have books, which is maybe a third, together with newspapers. And then we have Wikipedia, code, and other sources as well. After we established this extended and base corpus, we have to create subcorpora that was domain-specific to test these models on different scenarios. For example, we created domain-specific corpora just with the books, with the copyright-protected books, with the copyright-protected newspapers, with a combination of both to see whether adding or removing this material was making the models better or worse. We did the same for fiction. We have a small domain-specific set for fiction, for non-fiction, and then also including something that we internally call factual, which is non-fiction books plus newspapers. And then we have originally written in Norwegian books, originally written in Norwegian books plus newspapers, and then translations of the books. We also gather around 5,000 instructions, and this is important because it did not exist for Norwegian, any sort of instruction following dataset. These datasets are useful because it makes the models behave like a chatbot. When you ask the model a question, and instead of getting another question back, the model tries to reply to your question, is because they have been trained on instructions. They are able to follow these instructions. We didn't have any kind of data set for that in Norwegian, so we have to collect it ourselves. We collected these 5,000 instructions in different categories and domains, from reading comprehension, words and expression, but also Norwegian culture, across a set of different domains: arts, entertainment, food, language, history, politics, sports, but just 5,000 is not nearly enough. One of the oldest instruction sets in English has around 1 million instructions. We only have 5,000. The models were trained following the structure showed here. This is probably maybe too much information, but I think it's important to explain that this column of GPU hours can be directly translated to CO2 emissions. However, when you use these kind of accelerators, they usually offset these emissions. So we decided that instead of reporting on carbon emissions, we were just going to report on the actual number of hours needed to train these models. These models that were trained from scratch and also from pre-existing ways, from pre-existing models, like Mistral in our case, took the longest. We trained the base and extended from scratch, but also from pre-existing Mistral architecture with the data and the weights and everything. Those are the warm started models, and they took the longest. And even though they were trained for around 50,000 GPU hours, they are heavily undertrained, because the purpose of the project was not to produce the best performing model for Norwegian, but to be able to compare what's happening with the training mixture. We also have the domain tuned models, which are built on top of the model trained from scratch using just base. So we could ablate what's happening when you add fiction, not fiction, newspapers, factual information, and so on. And then we added instruction following sets on top of these core models just to see if the performance was getting better or how important was the addition of the copyright protected material. Evaluation was a bit complicated because we didn't have a lot of data sets to evaluate on Norwegian. But looking at the literature, we basically gather around 28 different tasks that are commonly used for doing the evaluation of natural language processing and language models. And then we group them into 9 higher level skills. This is an arbitrary way of grouping these tasks, but we needed to convey the results of our research to people that were not technical, that they didn't need to understand, like the Tatueba translation task. They know about translation, summarization, sentiment analysis, common sense reasoning, but they don't know about MMLU, Pro, ARC challenge, or things like that. So this is a table summarizing some of the different skills that we were trying to test our models on, the different types of data sets, specifics that we had, whether they included training sets, whether they have the sets, whether they were already in Norwegian, whether we have to translate it to Norwegian or not, whether they were machine translated, whether we have to redo it again, everything, and who was in charge of actually doing all of this. Some of this we have to do ourselves from scratch, a lot of them. We actually had students working with us through the universities, both Oslo and NTNU, and they did an excellent job because we didn't have a lot of time. Everything was very rushed, and they did a great job. We have to put together the annotation guidelines. We have to put together the UI for the annotation. We have to put together the collection of the data, the review for the quality, and the actually putting together the data sets. On top of that, we needed a framework to actually run the evaluation on the models. Because running evaluation is also very compute demanding. You still need to run these models in inference. Inference is roughly 3 times cheaper to run than training, but still needs accelerators to be run. And the bigger the model, the more time you need. We set for 7 billion models in size, because they represent a good trade-off between performance and compute needs. So to run these models, you need a GPU, even in inference. And when you run all of this for every model, for every data set, you're looking at a lot of compute hours just for doing evaluation. We collected around 2,000 different scores across 30 or more, I think it's more than 30 different tables. Experiments were repeated, some of them up to 4 times. We averaged through different prompts. We have what is called K-shot settings. That is, how many examples you give the model before you ask it to do a task. For example, you're want the model to do a translation, and then you present the model how translation is done. And you present it with one example, 4, 5, 8, 16. Usually, the higher the K shot, that's how it's called in the technical jargon, the more examples you present the model, the better the model behaves. You have to multiply all of this by 8 different K-shot experiments. So it was a lot of data, a lot of data. This is one example of the common sense reasoning Q&A, question and answer data set that we have to put together ourselves. In here, the question is what happens to a dog before someone puts up posters of it? And then the correct answer is A, it goes missing. But then we modify slightly the task formulation. We use different prompts for the model, and then you collect the answer of the model using different prompts. And then you can do average if they're using kind of the same metrics, and then you have to somehow aggregate all of those results. This is how the tables look like. We have like 34 more of this, and it was impossible to show this information to the right holders organizations. They wouldn't probably understand everything that is displayed in this table, like bleometry, CHRF metric, the deltas between the random choice, the BERT score. There's just too much information. So we have to settle for something that was kind of possible to digest. So what we did was we used these 9 higher level descriptions, agglomerating a lot of the results from these tables. And then we used the sum of all the metrics that were not possible to average because they were using different calculations for the metrics. You cannot easily do, for example, an average of BERT score plus accuracy or BERT score plus F1. That doesn't make sense. So we average metric-wise, and then just the sum per higher level scale. These are the results for the core models trained from scratch. And you can see how just adding a little bit more of internet data plus the copyright-protected newspapers and books is making the model perform a bit better than the base model. The base model didn't have access to any of the copyright-protected material. This is the Mistral model, which we use as a base for the warm-started models. So having complete control of the training material and complementing it with internet material, we were still unable to beat Mistral 7B. That points in a lot of directions, but that's probably for the audience to make the conclusions. When we train on top of Mistral, using both our base and extended models, we beat Mistral easily. And the difference you can see between base and extended trained from scratch gets smaller in relation to the difference between extended and base trained from a pre-existing model. So the material still has value, but the value seems to decrease when you're warm starting your model with another model that is available out there. These are the ablations that we run, complementing base with the books, newspapers, fiction, nonfiction, and so on. And you can see that in almost all cases, you can see a boost in performance in general, except for fiction and the translated books. You can think that maybe the reason is because the translated books and the fiction books is the smallest of the data sets, but actually there is something more profound, deeper about fiction that is making these models perform worse. The best performing one was the addition of newspapers, or the addition of newspapers plus non-fiction books. That is, the addition of kind of factual information from the books. When you average the different gains across the many different higher level skills, you can see clearly that fiction is making the model perform slightly worse than the addition of other material. We can split apart this information for all the different higher level skills that we have. And then the picture is a bit harder to read, because sometimes you can see how books or right holders combining newspapers and books make the models better. Sometimes adding translated material, you can see how it's making everything worse. In almost every single task, the addition of fiction is making the model either performing worse or not performing as good as just training on base, except for the variation and readability. And this is interesting because all the other skills that we have are designed around common practice in natural language processing. We realize that we don't have a proper way to evaluate fiction. We don't have a way to evaluate how creative the model is. We don't have a way to numerically account for the fact that a model is producing good fiction. The only proxy that we have, it was how readable the text is and how diverse the text is. And in that specific skill, fiction is performing much better than all the other ablations. But again, the addition of fiction in general is not performing very well. This is also due to the fact that all of these common higher-level tasks that we borrow from the literature are probably designed around the monetization of these models, unlike fiction. Finally, when you compare these core models and then you train them a bit further using this instruction following capabilities, you expose the models to be able to reply to questions, we saw a constant boost in the performance. No matter what model you started from, either base or extended, either from scratch or from pre-existing, the models just got simply better. You expose this model to question and answer pairs, and the models just get better. This is also a flaw in the way we do evaluation, because sometimes you try to evaluate by asking the model questions. That's a bit unfair, because in most cases, the models we trained in the project were just pre-trained models. They were not supposed to follow instructions until you do instruction tuning. And that's what we did, just to make sure that the models were performing still well. Interestingly, when you start training a model, and you use, for example, Mistral as a base, the difference between using copyright-protected material and not gets very small. And if you add instruction-following material to the mix, the difference is just negligible. You can see how here is 503.89, and here is 503.36. The difference is just very, very small. There is still value, though, because we don't know what kind of material was used to train Mistral to start with. We just don't know. They're not going to publish it. Llama's not going to publish it. OpenAI is not going to publish it. Gemma models, we don't know what they're trained on. So to conclude, I think that we now have empirical evidence that support the thesis that publisher-controlled, copyright-protected material actually improves and makes for better models. And to some extent, this seems to be mediated by the non-fictional content. One-starting models usually reduce the impact of using copyright-protected material. And instruction fine-tuning consistently boosts the performance of the models, possibly because the way the evaluation is usually designed around LLMs. I know I'm a bit out of time. So for the future work, we have to scale different models and architectures. We need to do more work on genre-specific fine-tuning, create better ways of benchmarking fiction, for example, on creative writing, plot understanding of descriptive generation. We need to explore other traceable models, like OMO, for which we know every single data set that was used in the training. And then we have to run longitudinal analysis on the diachronic effects of using different periods in the training of this material. This research has some indirect results. It was informing the negotiations with the right holders. We got knowledge at the government level. We got funding to create a new unit. That's the Sprack Modeller, the language models unit I'm head of. We got specialized in-house hardware. We got a central role in the AI ecosystem in Norway, and we are also mentioned in the digital strategy and budget lines for 2025-2030. And as for the status of the agreements, even though the project was not related to that, it seems like both the newspapers and books representatives have agreed on the main principles for the agreements. There is a possibility of a new licensing scheme that would allow the release of models trained on copyright-protected material. And now the ball is the politicians. We need funding for this, and it needs to come from Parliament. There is a review of the national budget in May, so they have to decide how they want to proceed with this. We did our work, everyone agreed, and now it's on their side. So thank you very much, and I'd be happy to take your questions.